I have to minimize it, right? No need. Do I have to minimize it? You come and go, have a nice time. No, we don't stand the right way. Good afternoon, students. Can we start the class?
Yes, ma'am.
Good afternoon, students. Have all of you settled down?
No, ma'am.
Okay, quickly,
Yep.
please settle down. Hmm?
We need some time possible.
Okay, I'll wait for 2-3 minutes more. Whoever talks will be giving answers for the numericals. I'll call out your name, then you will proceed with the numericals. Yeah, those are sitting at the back of front. Someone occupy the middle. Hafiz, Deep and Madhu Naran, Chandresh. Yes. Yes. Occupy this place. Yes, Deep. Deshman, inform. We all settled and we can do the session to inform. Yeah, from now onwards there will be pin drop sales.
Ma'am, let's start.
Okay.
Yes, ma'am.
Okay. In the last class, I left one question for you. Do you remember that? Yeah. Have you solved that question? No, you only will get numbers. You only will get numbers.
Please take the mic from ma'am and respond back to me.
MG plus FGS, NGS 2 grams of MG and 2 grams of sulfate. And there are lot of amounts of MGS.
Students, please pay attention and quickly settle down.
Get up and close the door now. If they are not done, inform her that they are not done.
Ma'am, we are not done the problem.
Why?
We have tests going on. Should test.
Agreed, but it is in the benefit of your own interest that you will be getting more marks, and these questions are for practice. Let's quickly recall what we did in the last class. Can you see my screen?
Yes, ma'am, we can see your screen, ma'am.
Okay, this was we in the last class, we discussed about the limiting reagents. Limiting reagents are those which limit or stops the reaction. If you have two ingredients, one of them can be in a smaller quantity so that reaction cannot be carried out further, right? And that particular reagent which is consumed completely in the reaction is called as limiting reagent for that particular reaction. I believe it helps you in recalling what we were doing in the last class, right? So what we were on the basis of this, we decided to solve certain question. The first question was this, that how much magnesium sulfide can be obtained from each? Yeah.
Can you zoom in?
Yeah, I can.
Now, okay, ma'am.
So in the last class, we did this problem that how much magnesium sulfide can be obtained from each 2 grams of magnesium and sulfur by reaction, magnesium reacting with sulfur, giving us magnesium sulfide, and it is the balanced chemical reaction. So first, one of the target was to find the limiting reagent, right? For that, I told you to find the number of moles, right? And since the number of moles of sulfur were less, and according to the balanced chemical reaction, 1 mole each of sulfur and magnesium was reacting, right? So therefore we said, since the amount of moles of sulfur is less, it will be the limiting reagent. Coming to the second part of the question, that how much magnesium sulfide can be obtained from each 2 grams of this? What about the quantity? Now, can anybody tell me? This was your homework. Now, can you now tell me what was, how will you find it? Quickly, you have 1 minute to do it. Okay, I'll show you the answer. You could have done it in 2 ways. Either the first one or the second one. You have to consider sulfur because sulfur is present in the as a limiting reagent. It was simple that you multiply. The second option seems to be easier one. Take the molar mass or molar mass as 56, multiply it by number of moles as you have found it to be 6.24 or 25 to be rounding up. You can do it this way, right? You can choose either of the ways to solve this problem. Else you can apply the unitary method that 32 grams of sulfur produces 56 grams. So 2 grams, which was given to you, will produce how much? Is it clear now?
Same you will be able to get in.
Please respond, students. I'll appreciate or I will request ma'am who's there to kindly let me know what are students doing. If they are copying it, I'll just wait for one more minute. Else, I will
Ma'am.
move to the next question.
And we are copying.
Okay, once you are done, please let me know.
Okay, ma'am.
Okay, make it first. Complete with the informed rest of the informed they are completed. I will take this entire 1 hour to complete this. This question was given the previous class.
I believe you have done it.
Yes.
Yes, ma'am.
Okay, let's solve another question on limiting reagent. Here the problem states that 50 kilogram of nitrogen and 10 kilogram of hydrogen are mixed to produce ammonia. NH3 is named as ammonia. You have to find out, that is, calculate the ammonia, that amount of ammonia formed. Also, you have to identify the limiting reagent in the production of ammonia in this situation. I believe all of you know the reaction that N2 plus 3H2 gives us twice ammonia. This is the sign of a reversible reaction. If you want to know the atomic mass of nitrogen, I can tell you it is 14. Atomic mass of nitrogen is 14. Hydrogen, you know it is 1. If you have any query, you can ask me. I'm waiting for your responses.
Give to them, Monisha, Paisa, and Ma'am.
Yeah.
Hydrogen is the limiting reagent, ma'am.
Okay, let's see. First of all, as we did in the earlier question, we have to find the limiting reagent into it, right? Or for doing so, we have to first of all find the moles of nitrogen and hydrogen. Then we can decide like this. I believe you are able to find the number of moles, right? For nitrogen, I have given you 50 kgs. So it has to be 50 into 1000 divided by 28 because it is nitrogen N2. Had it been only N, then that you should have divided by 14. So in this case, you have to divide it by 28 to get it as 17.86 into 10 to the power 2 moles. In case of hydrogen, you are given 10 kgs, right? So 10 into 1000 divided by 2. It is H2. For hydrogen, it is 1. H2, it will become 2. So the number of moles of hydrogen will become 5 into 10 to the power 3 moles, right? As you can see that the ratio of moles of nitrogen is to hydrogen is 1:3. That means the further solution can be done like this. That 1 mole of nitrogen reacts with 3 moles of hydrogen. So therefore 17.86 will react with how much? You have to multiply it by 3. So that means 5.36, but you have only 5 moles. That means hydrogen is the limiting reagent. Is it clear to all of you? If you are saying something to me, to please be a bit louder.
They are copying it.
Okay, please copy it and let me know.
Okay, ma'am. Ma'am, can you show the previous slide, ma'am? Thank you.
Welcome. Are you saying something to me?
No, ma'am.
Should I flip it to the next slide? Please copy it quickly so that we can either solve more numericals or learn the next concept.
4 minutes, ma'am.
Okay. Have you noted down?
Yes, ma'am.
Okay, let's do, probably this is the last question for the day. 20 grams of sulfur on burning in air produces 11.2 liters of sulfur dioxide, that is SO2 at STP, which means at standard temperature and pressure. The percentage of unreacted sulfur is. You have to find out the percentage of unreacted sulfur. We mean to say in this question that when sulfur and oxygen react, they form SO2, sulfur dioxide. And we are assuming out of 20 grams of sulfur, the entire amount is not burnt. Right? So that means whatever is left, we want to find out its percentage. And talking about the atomic mass of sulfur, it is 32. So can somebody tell me how are you proceeding in this question?
Ma'am,
Yeah,
can you solve it, ma'am?
okay. So here is the solution. It was simple question based on mole concept as well as stoichiometry. I have given you the reaction. I have told you the atomic mass of sulfur. So the first step is 32 grams of sulfur. We know it from the mole concept that 1 mole is equal to 22 liters at STP. 1 mole our atomic mass. We can choose any one to solve it. So we would have used this equation. 1 mole is equal to atomic mass is equal to 22.4 liters. The atomic mass of sulfur, as I told you, is 32. So we know that 32 grams of sulfur is going to react with 22.4 liters of oxygen. So the task was how much will react it with 11.2. To me, I can see 22.4 liters divided by 2. That is half of it. Right? So if I am taking 11.2 here and 32 by 2 means 16 grams. Or you can solve it by unitary method as I have done it here. Right? So the amount, you were given total 20 grams. Remember? In the question, I gave you 20 grams of sulfur. So out of 20, 16 has reacted. That means how much is left? That is 4 grams of is left, right? So what is the percentage? Amount left upon total into 100, that is 20%, right? The question was pretty simple, but I understand sometimes we are stuck up with so many concepts that we are not able to pick which one is to be applied over here, right?
Yes, ma'am.
Okay, please note it down quickly so that we can move further.
We may go the other. Make it fast. Stop talking. Then you can work faster.
See, students, to me, it's very simple, and you should, by this time, you should be able to do it much more faster. I have already shared the list of elements whose atomic mass you must know. So by now we must be bit quicker in it. Please remember, we always have exams to assess what we have learned, and the exam is always a time-bound activity. We do not get a infinite time to solve the numericals. So now onwards, I'll ask all of you to put more effort in reducing the time of solving a question. Certain numbers should come click to your mind very quickly so that the solving a question becomes easy to you.
Okay, ma'am.
Have you copied it down?
Yes, ma'am.
Okay. So now we will move to the next chapter. With this, we come to the end of the chapter 1. That was some basic concepts of chemistry. I have tried to cover as many various types of questions as possible for all topics and subtopics related to it. Now it's time to study the next chapter, which is the structure of atom. Before that, I'll again reiterate the fact, please pay attention to mole concept, balanced chemical equations, and atomic masses, right? With the help of these three basic concepts, you should be able to grab or score highest marks in this chapter.
Okay, ma'am.
So the next task is to learn the chapter number 2 of your book, that is the structure of atom. I have just pasted the syllabus for us so that we do not move here and there from the syllabus, right? So I will like to start the chapter not from the beginning, because that is bit historical perspective. We can always do it later. I want to begin it with the numerical section of it, where we talk about the quantum numbers. I would like to start the chapter with quantum numbers or Aufbau principle. Can somebody tell me what is Aufbau principle or what are quantum numbers? What is the idea you people have about them?
Ma'am, we don't know about it, ma'am. We are
Chapter
not-
2,
That's it, ma'am.
you have not started chapter 2 in the school?
We started, ma'am, but we are not come over this topic.
Okay, till what you have done it in the school? Can somebody apprise me about that so that I can pitch in the same?
Ma'am, till Heisenberg uncertainty principle, ma'am.
Okay, so that means I'm going to pick it from where you have almost learned down. Okay, no issues. So before that, we have to recap what Dalton's atomic theory says, right? The reason, although the Dalton's atomic theory is in the syllabus of chapter 1, but I felt it is more relevant to begin the chapter 2 with it, because it deals with the atoms and atomic theory. So what led to scientists to find out what is inside a material? Material, a substance. Material can be a substance or element or a compound or a mixture to us, right? They believe that earlier thinkers, I have put the word thinkers, not the scientists, because at the time, the philosophers, the people who believe them to be a connect between God and the human being, used to be a scientist also, right? Theosophus was one of them. So they started thinking that everything, including human being, are made up of matter. Matter, we know, is something which has mass and occupies space. So they believe that it is made up of particles. Just a pictorial image to tell you that if you have a beautiful gold bangle or any gold article, and if you start cutting it, maybe doing it 100 or 1,000 times, that it is made up of atoms. Ultimately, you will get an atom of gold. Please remember, I have put a note there, an imaginary representation. We must remember that atom cannot be seen. Don't take atom as something as concrete. Concrete means having a fixed structure. Like look at your bags, which you carry to the class. They do not have a rigid structure. Why? Because you can put, someday you can put 10 files into it, someday you can put only 4 files into them. Their volume can change, right? Similarly, atoms, although it has a outer word structure, but the volume is not specified. But for atom, we cannot say it for sure. Although we draw it as circles, right? If you recall your class 9, where you say the atom is made up of proton, electron, and neutrons, and the electrons are filled into them, right? So that way it seems to be rigid, but it is not. Then what was Dalton's atomic theory? After scientists realized material can be divided into atoms. Now, what is Dalton's atomic theory tells me? There are 4 or 5 points. Can somebody in the classroom can recall it for the benefit of others?
Atoms neither be created nor be destroyed.
That, okay. Any other point? So the point number 1 is clear to all of you, which is there on the board, that all matter is composed or made up of extremely small particles, which are called as atoms. Atoms of a given element are similar, identical in size. That means if I have gold, the atoms of gold should be identical. Again, remember, if we are talking about the Dalton's atomic theory, they are identical in size, mass, and other properties. Like if they are reacting, not reacting, everything. Size, mass, color has to be identical. This is what Dalton's atomic theory says to us. Now, atom, as somebody from the class has correctly said, they cannot be divided further. They cannot be created, they cannot be destroyed. That was also one of the points or one of the salient features of the Dalton's atomic theory. Now then they said that we know even today. Water, what is the formula of water? I think all of us know the formula of water is H2O. Write any formula. You will not be able to write it in fractions. As per your understanding, you write sodium chloride, magnesium chloride, copper oxide, you write any calcium carbonate, you will always be finding them having the simple whole number ratios. In water, we can say hydrogen atom and oxygen atom are reacting in or are placed in 2:1 ratio, right? So these are the 4 salient points. If you can, you may put it into 5 points also, because by the atoms cannot be subdivided. That can be put into different forms. Now, if I talk about the modern atomic theory, do you have any idea what does modern atomic theory says? Any idea? The first difference from Dalton's atomic theory is atoms. In the modern atomic theory, we say atom can be divided or atom is divisible into, do you know the name of the particles? Come on, you have done half of the almost chapter. Tell me the name of the particles.
Proton, ma'am. Proton.
Yeah.
Ma'am, proton, neutron, electron.
Yeah, correct. As per your books, atom can be divided into at least 3 types of particles: proton, neutron, and electron, right? We know that proton is positively charged, electron is negatively charged, and neutron does not have a charge. Please remember the represent, or please make the representation as I have shown it to you here. Reason being, look at the comparative sizes. Whenever you are drawing a structure of atom, please remember, first thing, they are imaginary things. Number two, they have to be always drawn on a comparative scale: proton, neutron, and electron. You can see that proton and neutron are of almost similar size. Electron is almost negligible, right? Here are the 3 basic characteristics of the basic particles: proton, neutron, and electron. If you don't remember, please note them all. Do you want to note them or should I move ahead?
No, ma'am, it is already in the book, ma'am.
Okay, clear. Now coming back to this point, atoms can be divisible, or atoms are divisible into proton, electron, and neutrons. Beyond that, if you just want to know, there are many more subatomic particles which are not in your syllabus. One of them being mesons, MESONS, right? And even mesons are of many types: positive mesons, negative mesons, neutral mesons. Then we have positrons. So we say they are divisible into proton, electron, and neutron, and many other particles. I'm emphasizing on this point so that whenever you get a question, a multiple choice question where you have to choose the correct answer, if you have to write it is proton, electron, and neutron is correct, they may be asking for more of them, right? So they are 3 are just representative. Now, the second point, they can be subdivided, right? That is what is replacing it. Atom is divisible, right? Now, atoms cannot be created or destroyed. Do you agree with it?
Yes, ma'am.
Atom cannot be created. If I say they can be, will you be understanding the same? Will you agree with me or not?
No, ma'am.
Okay, you have to. Have you heard about the formula E is equal to mc square? It is called
Yes,
as Einstein formula, according to which, where c is the velocity of light, right?
Yes,
If
ma'am.
something is moving with the velocity of light, it can be converted into energy. Does this formula tell us so or not? I'll say this formula tells me this, that matter can be created or it can be destroyed. But these are not chemical reactions. These are called as nuclear reactions. In a nuclear reaction, matter can be created or it can be destroyed, right? Can somebody tell me what is the source of energy of sun's light? We call it as, you can note down, this is nuclear fission. There are 2 types of reaction. I'll just take up a new slide and then explain it to you. See, you have heard about the chemical reaction, right? There is
Yes,
another set of, this is a nuclear reaction. As the name suggests, in these reactions, nucleus must be reacting. As of now, you are knowing only about the chemical reaction in which the electrons take part. Now, nuclear reactions are of two types. One is called as fusion, or more precisely, it is nuclear fusion. Another one is nuclear fission. Fusion means that something is uniting. And fission means breakdown. You have biology still class 10, and there you must have heard about the different type of fission in amoeba and paramecium, the unicellular animals. How many of you have heard about the Hiroshima and Nagasaki incidents? When the bomb was have you heard about the ongoing Russia and Ukraine war?
No, ma'am.
You know that. So what is they are using? They are using uranium, U-232. And with the help of neutron, they are breaking it down into, this is neutron's representation. They are breaking it down into barium and krypton and lots of energy, which destroys the cities, right? Talking about nuclear fusion, and it is a source of energy of sun. Fusion reaction is taking place there. Two hydrogen atoms combine to give helium, right? So, and again, unlimited amount of energy is being released. Ultimately, in both the reactions, in fusion and fission, matter is converted into energy. So the second thing or the third thing which Dalton said, that it cannot be created nor it can be destroyed. That is incorrect. It can be destroyed. It can be created. If you have heard about a term or called as radioactivity, do you know, have you heard about it? When you go for a X-ray, or whether if you sometimes, when you are not keeping well or somebody in the family is not keeping well, you need to go for a X-ray. Remember, you are asked to stand by outside the room. There is a danger mark written, drawn over the wall, right? So that is radioactive elements are present there. Radioactive elements are those which keep on deteriorating at their own. You must have heard about C14, yeah, carbon-14 dating, which is used for finding out the age of an individual or a plant. If you look at a plant which is having such a huge or a thick stem, how do you find out its age? You cannot, it is 1600 or 1800 years of age. Similarly, you can determine your age also with the help of carbon dating, right? If I know some procedure that they take the left hand wrist, and from there they find out what is the percentage of carbon-14 which is present in your body, and from that they decide whether you are minor or major. Of course, they cannot tell you what is your exact age in terms of years and months, but they can of course say whether you are above 18 or below 18. But they can predict your age between say 17 to 18 or 18 to 19, right? Are you getting my point or not? I cannot hear anything from you. It means I am just saying something and you're not able to understand it.
Ma'am, can you repeat it again, ma'am?
What?
Nuclear fission.
Nuclear fission. See,
Yes,
fission, okay. Fission means breakdown, right? This is U-232 is uranium. It's an element. You will do it in the next chapter, periodic classification, right? Uranium, its atomic mass is 232 and 236, etc. When you bombard a uranium atom with neutron, it breaks down into certain smaller elements. That is, one of them is barium. And this one is krypton. And enormous amount of energy is released during it. And it is the principle of, it is used, this reaction is used in making atom bomb. If you go, as you say that you have heard about Hiroshima and Nagasaki, you know about the ongoing Russia-Ukraine war, you must know that headline says they threw atom bomb on a particular city. The entire city is destroyed. Similarly, if I talk about nuclear fusion, fusion means, as I told you, uniting. They unite. Two atoms of hydrogen combine, right, to give you helium. Its atomic number is 1. They combine to give you helium, atomic mass 2. And again, lot of energy is given out in this reaction. As a result, the sun shines so brightly that we cannot even stand in sun for 5-10 minutes over there, isn't it? So, I think, is it clear what is nuclear fission and what is nuclear fusion?
Yes, ma'am.
Okay. Now talking about the radioactivity. Radioactivity means, like we in the class 10th, or rather in class 9th, you heard about 3 isotopes of hydrogen. This was protium, deuterium, and the third one was named as tritium. Right? Similarly, carbon has 2 isotopes, C12 and C14. The C14 isotope of carbon is said to be radioactive. Radioactive substances are not stable. What they do, they keep on emitting certain harmful radiations, which are harmful for us, but useful in some techniques. They keep on radiating. If you are interested, I can tell you they radiate alpha, beta, and gamma rays. If it is relevant somewhere, we will talk about them in detail, because earlier radioactivity was part of your syllabus. Now it has been deleted. But I have to teach you that particular section so as to tell you that atom, it's not that necessary that every atom is stable. Radioactive elements or radioactive atoms will not be stable, right? Sometimes the human being carry out the radioactivity experiments, like as I told you, carbon-14 dating. This method is very often used for finding the ages of monuments, the big and old trees, and even human beings, right? That's all we need to know it for right now. Moving on to another terminology, we call it as artificial radioactivity. Artificial radioactivity means some atom was stable. Now, by a certain method, you are making it radioactive. Like all of you are sitting very nicely, coolly in the classroom. Unnatural phenomena. God forbid it should not happen. But if there is a tremors there, I'm not getting the word of, there are certain waves inside Earth which are moving. You can feel them and you may get down, or you may just go to your back, or some of your friend from your back pushes you. What happens? You fall in the forward direction. Similarly, there was an atom which was not radioactive. Carbon-12 was stable, right? I will just push it from some side. I will push or put some X-ray or UV ray or something. What will happen? It will emit a certain radiation and change into another element. You might have heard about people are trying to make artificial gold. They got some stable element. They did some certain chemical reaction and got new element. Elements after atomic number 100 are all man-made elements, and that is because of artificial radioactivity. The purpose of sharing all this information in nutshell with you to tell you that atoms can be created, right? Is it making sense?
Yes, ma'am.
Okay. So coming back to what we have. So we have said that in modern, if I talk about the modern periodic table, we'll be saying atoms can be, atoms are divisible, they can be created and created by artificial radioactivity, as I told you, and they can be destroyed by nuclear fission, or rather nuclear fusion. Now, atoms of different elements can combine in simple whole number ratios to form chemical compound. It is also not correct. There are certain compounds, some people call them as mixtures, but technically they are compounds because they are stable. I believe all of you must be having any article or a part of article made up of steel with you. How many of you have a steel lunchbox with you? Anyone? A steel lunchbox, a steel bottle. Is it used at home? In any utensils? Have you seen steel?
Yes, ma'am.
Now, what is steel chemically? You are a science student now. So steel is chemically made up of iron. I believe you understand the symbol of iron is Fe. It contains iron, chromium, it can have manganese, and it can have many other things, right? More importantly, it has carbon. If you look at the utensils of your home, most of them, I'm not too sure about your homes, but I'm sure of my home. Most of the articles or the containers which we use are made up of various varieties of iron in which carbon is mixed, right? This is an example of a cage compound. What is a cage compound? In the cage compound, and we should be studying about them in detail in class 12th, the chapter named as DNF block element. The cage compound means you must have seen a bird inside a cage, right? So iron has atomic number of 56 and that of carbon is simply 6. So we can say that if this is the iron atom, which is quite big in size, in between them, atom of, this is, let's say this is an atom of carbon. So it is an atom of carbon. This is an atom of iron, and various iron atoms. So technically they are called as cage compounds, and the difficult name is interstitial compounds. So therefore, and the formula of steel is iron 1.29, carbon 0.36. They do not have a whole number ratio because there can be 2 atoms of carbon trapped in it, or maybe 4, or maybe 3. So they do not have a specific formula, but they have a fractional formula, which can be, let's say, Fe 2.3, carbon, let's say 0.4. Is it clear? Please respond
Yes,
to this. Okay. So what we are trying to say, according to Dalton's atomic theory, whatever points they said, atom is not divisible. Modern theory says it is divisible, right? They can be subdivided further. They can be destroyed. They can combine in any ratio. Now coming to the second point, atoms of given element are identical in size, mass, and other properties. You know the reason why it is incorrect in modern atomic theory. Any idea?
No, ma'am.
Okay, tell me what is an isotope? What is an isotope? What is an isobar? I have just explained to you.
Ma'am,
Isotope. Yeah, please speak.
ma'am,
Yeah,
same atomic number, ma'am. Different mass number.
okay, correct. See, I gave you the example hydrogen or carbon. We can have oxygen also. O16, O18. So what Dalton said to us, the atoms of all of an element are identical. Atom of gold will all be same. But what we are seeing, atoms of oxygen are not same, right? Oxygen 16 and 18, even O17 is known to us. Carbon 12, carbon 14, H1. In fact, every element has 1, 2, or many isotopes, right? So that point that all atoms of an element are same is destroyed. Now it does not exist in modern periodic table because we know the existence of isotopes. And what are the isobars? Can somebody tell me? What are
Same
isobars?
mass number.
Same number of, I didn't get you.
Same mass number, ma'am, but different atomic number.
Okay, I put it this way, atoms of different, you also said the same thing, that is correct. Atoms of different elements. That is why they're having different atomic numbers, right? See, like you have an example of argon. Argon and calcium both have atomic mass 40, but atomic numbers are different. It is 20 and it is 18, right? So that means existence of isotopes and isobar itself destroys that particular fact that atoms of an element, or all atoms of an element are identical, right? So you can write it down in your notebooks. Put 2 columns, Dalton's atomic theory and modern atomic theory. I've explained each and every point to you. You can put it down. So if you get a multiple choice question, say if I'm your examiner, I may give you 10 points and say, segregate them into 2 parts, which is modern atomic theory, which is Dalton's atomic theory, right? So you can, I can give you, you just have to write down all the points together. Theoretically, there cannot be a question seeing the pattern, new pattern. You should not be having write all salient features of Dalton's atomic theory or modern atomic theory. No, you may not get that question, right? So moving on, we have found out the subatomic particles are there, but what led to their discovery? That is the discharge tube experiment, Faraday's law. See, one of the breakthrough was Benjamin Franklin's experiment, where he found electricity. He found that atom is a charged particle. And the last one is artificial radioactivity. Discharge tube experiments, as all of you said, that you have done it in your classes. Can somebody tell me something about the canal ray experiment? Discharge tube experiments, as you said, you have done it till, you have done approximately de Broglie's equation. So this is a discharge tube experiment. Can somebody from the class throw some light on it? What you have understood from that? Please speak one by one. Take a mic from the ma'am and just speak.
Can you repeat the question again, ma'am?
See, as in your school, you have completed the chapter till de Broglie's equation. You must be taught about the discharge tube experiments, which led to the discovery of proton and electron, right? Can somebody tell me What is a discharge tube experiment? Discharge tube experiment or canal tube experiment from the point where the chapter begins for you. Let's put the question other way. How the electron was discovered? Who discovered electron?
J.J. Thomson, ma'am.
How? Correct. J.J. Thomson is correct, but how? There was an experiment which is in your syllabus. See, we said discovery of electron, proton, and neutron. So there are.
Cathode ray experiment, ma'am.
I didn't get you. Can you just be repeating it?
Cathode ray experiment, ma'am.
That's what I was asking. Okay, you might not have read it in the name of cathode ray. Canal ray experiment. You can note down the another name because examiner can ask that also. It is also known as canal ray experiment. That is CANAL. Canal ray experiment. Okay, so what he did there was, can just tell me in brief before we end up the class. I'm not able to hear anything from you.
Ma'am.
Yeah.
Ma'am, canal ray was discovery of protons and neutrons, ma'am.
No, neutron was not discovered like that. Canal rays were used for the discovery of proton and electron. We will talk about them in detail in the next class, or maybe we will pick up from above principle. And I will, since it is, I didn't get you, please repeat.
Ma'am, the electron was discovered by discharge tube experiment, ma'am.
Yeah.
Cathode ray.
Yeah. So in the next class, the first thing I will do, I will ask you about what you have done in discovery of electron, proton, and neutron. And then only I'll give my inputs and we'll proceed further. And please do remember to do your homework, right? You have to revive this concept. Discovery of electron, proton, and neutron. The theoretical aspect, you must know that. You must recall them. And I believe by the time your exam, as you said today, were over, will be over. Will they be over or not?
No, ma'am.
Even then, we have to do the first term, second term course. So I'll appreciate if you can revise them before you come to the class, right? So thank you for being there, and do complete the revision of chapter 1 and chapter 2. Do read this one. Have a good day.
Okay, ma'am. Thank you, ma'am.
Welcome.